Okay, well, this was a test on polynomial operations and complex numbers. Problem number 1, simplify completely. Anytime we have a negative under the radical, we know that's going to be I. So far, that means we have I square root of 48. We could put the square root of 48 in our calculator. Okay, that's 4 radical 3. So that is 4 radical 3. The I goes here in the middle, so that would have been your answer to number 1. Now, similarly, this one. For a moment, ignore the negative 4 and the minus sign. This part of the problem is just like problem number 1. When you see a negative under the radical, you know that that will be I. So that's like having I radical 27. Now, if I do the square root of 27 in my calculator, I get 3 radical 3. So that means that this is 3I radical 3. Now I'm going to bring back that part that I scribbled out, negative 4 minus. So this is negative 4 minus this, negative 4 minus that. Now, the trick is, that's the answer. We can't go any further than this. Some students want to put this together and make negative 7I radical 3 or something like that. But that would be wrong because these are not like terms. If I had negative 4I radical 3 and minus 3I radical 3, well, now I could put these together and make negative 7I radical 3. But if one of them has the I radical 3 and one of them doesn't, then they're not like terms and you cannot combine them. So that's the answer. Now, problem number 3 and 4 rely on a chart. And the chart went like this. Alright, to use this chart method that I'm about to show you, you have to memorize this chart making process. And it goes I squared, I to the third power, I to the fourth power. I cannot be simplified, so that's just I. I squared, we have memorized this one, that's negative 1. And I usually skip down at this point and do this one. I to the fourth power is I squared times I squared. So negative 1 times negative 1 is positive 1. That only leaves one option left, and that is negative I. So I've got 1, negative 1, I, negative I. These are the only 4 possible answers when you have I raised to any power. Now over here I think about quarters. 1 quarter is 25 cents. 2 quarters is 50 cents. 3 quarters is 75 cents. And 4 quarters is 1 whole dollar with no cents. Now, if I want to know which one of these 4 answers, because understand these are the answers right here. If I want to know which one it's going to be, what I do is I take this number and I divide by 4. So if I do 425 divided by 4, I get 106.25. The 0.25 tells me that this is the row that I want. So I is the answer. Okay, can I make this bigger? Sometimes it disappears. Watch to see if that dot disappears. Now I'll do the same thing over here. I'm going to take this 272 and divide by 4. You always divide by 4. I guess because there are 4 possibilities. So I'm going to take 272 and divide by 4. I get 68, no decimals. Alright, no decimals means we're in this row, 0 decimals. So that means the answer is 1, just the number 1. So that's how you do 3 and 4. Okay, let's move on to 5 and 6. Now, when you have a negative sign in front of parentheses, you need to treat that like a -1 and do the distributive property. Do not distribute the 3, only the negative sign. So -1 times 6, that's -6. -1 times 7, that's -7i. Then I'm just going to bring down the 3 and the plus 4i. I just brought those down. Now it's just a matter of combining like terms. 3 minus 6, that's -3. -7 plus 4, that is also -3. So we have -3 minus 3i. By the way, you should always put the I term second. So that would be the answer to number 5. Now, this is addition. Whatever you do, do not start multiplying these. That would be wrong, wrong, wrong. Alright, this is addition. When it's addition, the parentheses are not really doing anything. So it's just -2 plus 4i plus -5, I could have just put -5, minus 9i. So all we are doing is combining like terms. So the -2 and the -5 go together, and that's -7. The 4i and the -9i go together, and that's -5i. And that's it. That's the answer, number 6. Okay, for number 7, we need to do the distributive property right here. So if I do 3i times 5, that is 15i. Now 3i times -i, think of this as a -1. That's going to give me -3, but I will have I squared because I have I times I is I squared. Now you must know that I squared is -1. So this is like having 15i minus 3 times -1. Well, -3 times -1 is a positive 3. Alright, there's no more I here. Alright, the I squared became -1. There's no I. So right now I have 15i plus 3. This is basically the answer, but we are supposed to rewrite these to put the I term second. So we will just put 3 plus 15i for the final answer. Okay, looking at number 8. The key here for number 8 is don't just square these two terms. You have to write it twice. 5 minus I times 5 minus I. So you have to double distribute here. Alright, if I distribute the 5 times 5 is 25. 5 times -i is -5i. If I distribute the -i, -i times 5 is -5i. -i times -i is positive I squared. If I combine these like terms, now I have 25 minus 10i. They don't cancel. -5 and -5 make -10. Now I squared is -1. So this is like having -1. So 25 minus 1, that's 24. So I will have 24 minus 10i. And that is the final answer, 24 minus 10i. Alright, looking at problems 9 and 10, very similar. Our goal really is to get rid of any i's from the denominator. The way we can do that is by multiplying by the conjugate, which would be 2 minus I. Notice that it's not -2. I'm just changing the sign of the imaginary part. So 2 plus I times 2 minus I. The i's will wind up canceling out. I have to do the same thing in the numerator, so I will also do 2 minus I up there. So let's work this out and see what happens. I think I'll do this sort of off to the side a little bit. If I do 2 plus I times 2 minus I, and I'm going to double distribute this. So if I distribute the 2 times 2 is 4, 2 times negative I is negative 2I. Okay, now if I distribute the I times 2 is positive 2I. Positive I times negative I is negative I squared. Now these middle two terms cancel out. I've got a negative 2I and a positive 2I. So I'm going to bring down the 4. Now think of this as a negative 1. Okay, so it's like I have negative 1 I squared. Okay, I don't know why my 1 keeps disappearing, but I squared is negative 1. So it's like I have negative 1 times negative 1, because I squared is negative 1. That's going to change this negative 1 to a positive 1. So I will have 4 plus 1, which is 5. So that's why my denominator, which has no more i's in it, my denominator will simply be 5. Okay, now let's deal with the numerator, which I'll change colors for that. Okay, so my numerator was negative 3 times 2 minus I. This is just a simple distributive property. So negative 3 times 2, that's negative 6. Negative 3 times negative I is positive 3I. So I've got this negative 6 plus 3I. Now this is essentially the answer, but we are supposed to split this up into two separate terms by writing the 5 underneath each one of these two terms. So this will be the same thing as having negative 6 over 5 plus 3 over 5I. I just wrote the 5 under the 6 and again under the 3. Alright, that's how you should write your final answer for number 9. Number 10 is going to be almost the same thing. Okay, so I'm going to multiply this by 1 plus 2I. And I'll have to do the same thing in the numerator. 1 plus 2I, like this. Now, so if I do my 1 minus 2I times 1 plus 2I, alright, if I multiply this all out, so if I do the 1 times 1 and the 1 times 2I, so 1 times 1 is 1, 1 times 2I is 2I. Now I will distribute the negative 2I. Negative 2I times 1 is negative 2I. Negative 2I times positive 2I is negative 4I squared. Now these middle terms cancel each other out, so I'm going to bring down the 1. I squared is negative 1. Negative 1 times negative 4 is positive 4. So again, I'm going to have 5 in the denominator. So I've got that 5 happening. Okay, now let's look and see what's happening in the numerator. Just going to do that down here. Now the numerator was 3 minus 2I times 1 plus 2I. So again, I'm going to double distribute. So if I distribute the 3 times 1 is 3. 3 times 2I is 6I. Now I will distribute the negative 2I. Negative 2I times 1 is negative 2I. Negative 2I times positive 2I is negative 4I squared. Nothing cancels out this time. Okay, so I'm going to have 3. Now combining these like terms, 6i minus 2i is 4i. Now I squared, again, is negative 1. So this is like negative 4 times negative 1. So that will become a positive 4 with no I. The I squared is negative 1, so there's no I about it. So I just have a positive 4. Now if I combine these like terms, the 3 and the 4, that's 7. So that is 7, and then I just bring down the 4i. So that's what's going on in the numerator, is 7 plus 4i. Now this is essentially the answer, but again we're supposed to separate this into two terms by putting the 5 under the 7 and under the 4. So that would make 7 over 5 plus 4 over 5i. So that would be your answer for number 10. Okay, we're supposed to solve these next two problems using square roots, which is what you would naturally do anyway. So what you want to do is get the parentheses by themselves first. So you would add 3 to both sides like this. So that's going to give you 2 times x plus 3 squared equals 8. Now we want to get rid of this 2 before we start taking any square roots. So we would divide both sides by 2 next, like this. That way these 2's will cancel each other out. So that's going to give us x plus 3 squared is equal to 4. Now that the parentheses are alone, we can go ahead and take the square root of both sides. Now don't forget to do plus or minus when you do this. So the square root and the square cancel each other out, and you just have x plus 3 equals, square root of 4 is 2, so that's plus or minus 2. Now we just have to get x by itself. We can do that by subtracting 3 from both sides. For now, let's put that 3 in the very front. I always do that when there's a plus or minus. So that gives me x equals negative 3 plus or minus 2. Now if there was an I here or a radical, I'd be finished. But since these are like terms, I need to keep going. So just understand that plus or minus means negative 3 plus 2 or negative 3 minus 2. That's what plus or minus means. Now negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. So x equals negative 1 or negative 5. Okay, we will do almost the same thing for number 12. So again, we will get the squared part, the parentheses, by themselves. We will subtract 6 from both sides. So that's going to give us x minus 2 squared is equal to negative 16. There's nothing else here except for the parentheses, so we can go ahead and take the square root of both sides. Don't forget your plus minus. So that gives me x minus 2, alright, the radical and the square cancel each other out, is equal to plus or minus. Now this negative is going to be an I later. So focus on the square root of 16. That's 4. But because it was negative, it will be 4i. Now, to get x by itself, I will add 2 to both sides and put it in the very front anytime you have a plus or minus. So that's going to give us x equals 2 plus or minus 4i. Now these are not like terms because this has an I and this doesn't. So we really can stop here. x equals 2 plus or minus 4i. We don't need to go any further than that. Okay, next we're going to solve by completing the square. Okay, this is the one where we do half the middle squared. So in problem number 13, this problem is the first step has been done for us because there's already a blank space waiting for us to fill in. And like I mentioned a moment ago, the way we fill that in is we do half the middle squared. Half of 4 is 2. 2 squared is 4 again. So I'm going to put a 4 here. Now a common mistake is just to put the number on the left side. But to keep the balance of the equation, you have to put it on both sides. So when you do half the middle squared, put it on the left and the right. Alright, next we factor. So I'm going to take this trinomial and I'm going to factor it. You could use the star method, but to me that would be the long way. Negative 8 plus 4 is negative 4. When you're completing the square, which is what we're doing, these factors are always going to be the same thing. So that makes it really, really easy to factor using common sense. So x squared will be x times x. 4, normally we'd think, oh, well maybe this is 2 times 2, but maybe it's 1 times 4. Well, it's going to be 2 times 2 because they have to be the same. And looking at this sign, I know that they will both be positive. So I have this. So the point of writing it, of having it be the same thing twice, is I can write x plus 2 squared is equal to negative 4. Look familiar? Okay, it's sort of like when we had the previous two problems. So from here we're going to use square roots to solve. So I can now take the square root of both sides. Don't forget your plus minus. And this is going to give me x plus 2 is equal to plus or minus. Now the square root of 4 is 2. Because it was negative, it will be 2i. Alright, one more step. To get x by itself, I need to subtract that 2, and you should put it in the front. So that's going to give me x equals negative 2 plus or minus 2i. And these are not like terms, so we're done. Okay. Take a look at number 14. Now, this time there's a number here in the way. We're still completing the square. But we need to make this number a special number, and negative 7 is not it. It's not half the middle squared. So what I recommend is your first move should be to move that negative 7 out of the way. The way we can do that is by adding 7 to both sides. So I'm going to recopy this problem. So I have x squared minus 2x. I'm going to leave that space here, and now I've got the 7 over on the other side. You know, these cancel each other out, left a nice space. Now in that space I can complete the square, meaning I will do half of the middle and square it. Half of this is negative 1. Now negative 1 squared is positive 1. So that's the number that belongs here. A common mistake would be to only put it on the left. To keep the balance of the equation, you need to add it to the left and the right. Okay, so now I've completed the square. Now we will go on and factor this trinomial. You can be confident that it will factor as the same binomial twice. I've got 8 over here. That makes it so easy to factor that we do not need the star method. So x squared is x times x. 1 is 1 times 1. Now looking at this sign right here, I know that they will both be negative. Now, they are the same binomial twice. I can write that in a more compact form by putting x minus 1 squared equals 8. Now I can get rid of the exponent by doing the square root on both sides. Don't forget your plus or minus. The square root and the square cancel each other out, and we have x minus 1 is equal to plus or minus. Now the square root of 8 is 2 radical 2. Okay, so now we just need to get the x by itself by adding 1 to both sides. I'm going to put it right in the front. So I've got x is equal to 1 plus or minus 2 radical 2. Now because this has a radical 2 and this does not, these are not like terms, so they can't be put together. So I'm just going to stop. And that's the answer to number 14. Okay. The last two problems are involving the quadratic formula. So for starters, let's make sure we all remember the quadratic formula. And it goes, when you have a quadratic equation in the form ax squared plus bx plus c equals 0, the solutions will be opposite of b plus or minus square root b squared minus 4ac all over 2a. And you have to memorize this. There's a little song that can help you, and it goes opposite of b plus or minus square root plus or minus square root b squared minus 4ac b squared minus 4ac all over 2a, all over 2a. Now I could sing that a couple more times, but I'm not going to because this is a recording, and if you need to hear it again, you can just run it back a few seconds. So let's move forward. So for this problem, a is 1, b is negative 4, and c is 12. The part under the radical is known as the discriminant, and you always should calculate that first and separate from the rest of the problem. So this is called the discriminant. Okay, without the radical, just the b squared minus 4ac. So I always calculate that first. So b is negative 4. So b squared minus 4ac. Notice how I put that b in parentheses. I put everything in parentheses. You should too. If you put this in your calculator without parentheses, you will get the wrong answer. Okay, so my b squared minus 4ac, so that is negative 4 squared minus 4. I don't really need to put the 1 because that's not doing anything, times 12. That's negative 32. Okay, so that's the discriminant. Now I'm going to do the rest of the quadratic formula. So opposite of b, so that makes this positive 4 plus or minus square root. Here comes that negative 32 all over 2a. Well, 2 times 1 is just 2. So it's just a matter of simplifying this, guys. So I'm going to have 4 plus or minus. I know I'm going to have I. So forget the negative for a second, and what's the square root of 32? Well, that's 4 radical 2. So that means because of the negative, it'll be 4i radical 2. Now I'm seeing a common factor here among these three things. So that means Alright, among these three numbers, not including the 2 under the radical, I need to divide by that common factor of 2. I'm going to divide all three of these numbers by 2. Okay, if I do that, then I'm going to wind up with 2 plus or minus 2I radical 2. Okay, I could have put over 1, but you don't do that. Alright, you're going to lose a point for not simplifying. So this is the final answer for number 15. Okay, last one. Notice on number 15 we had 0 on one side. That's part of the formula. You have to have 0 on one side to use the quadratic formula. This does not have 0 on one side, so that means you need to get 0 on one side. And we can do that by simply subtracting 15 from both sides. So that gives us x squared plus 2x minus 15 is equal to 0. So now it is time for the discriminant, b squared minus 4ac. Okay, you always do that first. So b squared, so that's 2 squared minus 4, a is 1, c is negative 15. Not positive 15, negative 15. So this is the discriminant. Again, you don't need to put the 1. I'm just doing it so you can see the b squared minus 4ac. I don't want to confuse anybody, but I also feel silly multiplying by 1 when everybody knows that that doesn't do anything. So 64 is the discriminant. Now I will do the rest of the quadratic formula. Opposite of b, so that's negative 2 plus or minus the square root of 64 all over 2a, which in this case is just 2. Well, the square root of 64 is 8. So that makes this negative 2 plus or minus 8 over 2. Do not stop here. These are like terms. There's no I, there's no radical. By the way, there's no radical. Some students want to do the square root of 64 and then they put a radical 8 here. It's not square root of 8, it's just 8. So you need to do your plus or minus right now. So this means, here comes the plus or minus 8. This means negative 2 plus 8 over 2 or negative 2 minus 8 over 2. That's what plus or minus really means. So don't try to do the GCF or anything. Just do the problem. So negative 2 plus 8, that's 6. So that's 6 over 2. Negative 2 minus 8, that's negative 10. Negative 10 over 2. 6 over 2 is 3. Negative 10 over 2 is negative 5. So this is the final answer for number 16, 3 or negative 5. Okay, and that is it for this test.